Hello, I am Toshio Iwata, director of digitalfitter.com, and today I will show you an example of 6D sensor fusion by using accelerometer and gyroscope on this board. And I will use MotionFX library provided by ST Microelectronics to do motion estimation. And I also tell you about how to calculate quaternions by using this processor, and how to visualize the rotation of this board. The motion estimation is like this. The left is a real movie, the right is an estimated one. Here is Nucleo, a microprocessor board. It's connected to the PC through USB. And this is IKS4A1. It's a sensor board. It has accelerometer and gyroscope on it. And the microprocessor is programmed by the PC. This is a development tool for microprocessor. It's called STM32 Cube IDE. And the program is written in C language. And these two lines are function for sensor fusion provided by ST Micro. And we cannot see the function inside because they are provided as binary files. And this is the input of the function, and this is the output. So how to use these functions is written in this document. Getting started with MotionFX. It's for STM32 Cube IDE. It's called UM2220. So let's search for Kalman. Then we can see the functions MotionFX update and MotionFX propagate. There are some explanation of those arguments. And this document says the functions are based on the Kalman theory, and they are for Cortex-M4 microprocessor. And how to input the data is written over here. ACC, accelerometer in G, and gyroscope is in DPS. These two functions, MotionFX, propagate, update. The input is this one. The unit is G. Accelerometer is G. and gyro is dps. Now following the document, we put ACC values like this, and also put gyro values like this. So regarding to these units, please see the previous movie. Then we put data into these two functions and run them. Then we get data out, and quaternions are inside data out. Quaternions are like this. There are 4 values. And quaternions are calculated by processor, and they are logged into SD card, and we open it. It's like this. 4 values in a line, and there are a lot of lines, and the first 3 ones express how the axis is inclined in a 3D space, and the last one expresses how it's rotated around this axis, inclined axis. And we need to visualize these quaternions. In order to do that, I used this tool. This is Unity. It's mainly used for game programmers. And this is the one I have replicated the sensor unit on the Unity. And the blue one is sensor board, and white one is a processor board, and the green one is an adapter board. And this object is associated with a script to have it moving. So let's open the script. Then Visual Studio is started. The script is developed on this Visual Studio. And these are quaternions. They are copied by the SD card. And the number of quaternion is like this. Total 6144. There are many quaternions, and we put them into variables and increment n from 0 to 6143, and the variable is type of variable is quaternion. And these .x, y, z, w correspond to this x, y, z, w. And if we update quaternions, the rotation begins. Let's start. And there is a point to keep in mind. These 2 lines, y and z, 2 and 1, they are switched. Originally this was like this. In this case, the rotation is a bit weird. One axis goes opposite way. So let's see the axis of unity. It's like this. On the other hand, the axis of the device is like this. These are a bit different. Y and Z are replaced. That's why we did like this. So be careful of the difference between these two, unity and the device. Unity is a left-handed system and the device is right-handed system. I don't know if this is the best way. Anyway, this change can make it working fine.